Hi, I'm Phil, and today we're going to be talking about software reuse. Um, the main thing that I want to discuss today is the side effects of reuse, and this is from a former colleague of mine. The dark side of reuse is dependencies, and I think that that's a really clear way of putting this problem. There are side effects to reuse, and you have to know about them and deal with them. So what we're going to talk about today is why we would want to reuse software, what the reuse can look like, what dependencies look like, and then we're going to talk through a motivating example, and I'm going to share with you some example decisions that a software team might make and their side effects, and then we're going to sum up. So why is reuse a good thing? Or why is it perceived to be a good thing? Well, I guess in some sectors of the industry, there is an almost dogmatic belief that, if you are a professional, you would never repeat logic, and that if you do, that it's a cardinal sin. And I sort of maintain quite a more nuanced opinion about this. I've certainly wrestled with my idea of what good looks like, and the longer you spend in the industry, the more you'll have to deal with, choices. But there is a genuine trade-off there. When you copy code, you have to duplicate effort to keep it maintained. And there is a real opportunity for each of your duplicates to diverge and have different behavior, different logic, sometimes different bugs. And so to try and avoid that, or at least to try and contain the problem, we try to share code. And that's generally considered to be a good thing if you share code. But there is a side effect of sharing your code, and that is dependencies. And dependencies also lead to repeated effort. Partly because you need to test things again, potentially. Or if you don't test things, then maybe you create bugs. And in some cases, you'll need to maintain the other places, particularly if you change the contract or the signature. So what does reuse look like? Well, as I said before, generally it's considered a good thing. You might have a shared function or method, a piece of isolated object that does a particular thing, or a class that encapsulates some finite piece of logic. A library that collects together several classes or methods and does a coherent thing. You might have a shared API endpoint that lives on a particular machine. You might have a shared database or a shared table that, multiple applications deal with. And, duplication is a form of reuse as well. It's not what people tend to think of as reuse. But, I worked in an organization where we had some customization scripts, like that when a new customer came on, we'd get a recent successful customization, copy it, make some adjustments to it, and test it, and it would work. And one of the benefits of that is that when things changed for a particular customer, well, you could change whatever you liked. And you didn't have to worry about accidentally introducing regressions to any of the other customers' customizations. But if there were bugs in the section of code that you copied, well, obviously that bug would be in a lot of places, and you might need to go back and fix them in several places. If that was affecting customers, there's always a trade-off there. But I think generally that's sort of an extreme form of reuse that people would tend to avoid. Dependencies. These are often not introduced deliberately. They're sort of a consequence of reuse or of technology choices. And what might that look like? Well, if you change a method, you might not change the signature, but if you change the body and you change the behavior of it, it might mean that you affect one of the callers. If you do change the signature, well, absolutely, you will have to change your callers. If you, and this is a little bit different, if you collect together several different pieces of code because they're shared, then sometimes if you change a piece of code, there might be another piece of your application that doesn't use that code, but because it's using the shared library, it will have to be rebuilt as well. And this one is such a difficult problem. So having a single version of the library and a particular executable, it's such a difficult problem to solve that it's been given a particular name in the community, and that is DLL hell. And what this means is that if you have several libraries that you depend on and they require different incompatible versions of a different library, and you're only allowed one version of that, well, you've got a difficult problem deciding which version of everything that you install, because you might not be able to find one at all. Which means you might need to decide which of those two things that you want to have in your application, or split them out into different applications. If you're thinking on a web service, then having a shared API can mean that you have changing that thing can break several callers. There's ways to get around that. A lot of people use versioning as a mechanism for doing that, and what I mean by that is that it's clear which version of an API that you're calling into, and there's change control on that particular API. I say backward and forward compatibility there, and what does that mean? Well, if you can trust your callers to tolerate certain kinds of changes, then you know that they will be forward compatible with certain changes that you can make. And so an example of that is you might return a new property as a result of an API call. Another backward compatible change might be that you add a new optional parameter on an API, which some callers might not know about, and they don't supply it, and that might still be fine. It won't break your caller. And finally, there's a lot more examples of dependencies out there, but this is a handful. A busy service being used by one chatty system part would potentially slow down an entire system. You've got one node that's running a thing, several callers. If there's one caller that's really, really busy, then it'll slow it down for everybody. Okay, so we're going to talk through an example, and I've got that right here. So for some context, we've got this application here, which this company sells widgets, and they sell them to lots of different customers. And so their widget dialog looks like this. You set up the name and the price, and their customer dialog looks like this. You set up a name and then an account number maybe. And if a customer wants to buy a widget or some widgets, they log a transaction, they keep track of that. Now, obviously, a real system would look a little bit more complicated than this, but I think this captures the kind of relationships that you might see in a real application. Okay, so this is what their line of business app looks like at Widget Sync, and everything is happy. They have an app, and there are 3 forms in that app. The widget form, which talks to the widget table, does a SQL request to show all of the widgets, and then if you want to create a new widget, it does an insert. If you want to change a widget, you do an update, and so on. And this transaction form will select a widget. Now, this is important. It needs access to the name of the widget. It's not palatable to tell your internal users. Sometimes I think internal users can be treated a little bit like second-class citizens, but this would certainly not be tolerable for a customer to have to type in the primary key of their customer ID, because they may not even know it, and the widget ID. But in this circumstance, we're not making the users do that. I presume that they would click on here and either do a search, or maybe they've only got a handful of customers and a handful of widgets, and they can put in a drop-down list here. But they have to get at that data so that they can show the name, not the ID, on this page. All right. So that's what their line of business app looks like. And then one day, one of their leadership team says, we're going to start selling this on the internet. And so they have to come up with a web presence. And what does that look like? Well, we already have this database there, so we're going to use it again. And we're just going to use the same tables that we already have there. But the developers say to the team there, well, we've had to build some stuff here that we also had to build over here, and I think that we can make our lives easier and make this less difficult to manage. So we are going to try and get some reuse. So this is what they build. They have built and you could imagine that this is a shared DLL, one that gets loaded into the line of business app, and then again gets loaded into the web presence. And they've got some options here. This transactions object could go directly to the data store, just like the original website did. But actually, if you did that, maybe it's not the right choice, and perhaps they should go and reuse the logic that's there. Just going to, maybe that is a better choice there. But that, I think that comes down to a trade-off. How expensive it is to load these things, how many of them you want to do, and what does a search look like? How many of these you need to read? And maybe it's not the right choice. Maybe I should go straight there. The other option is, maybe the reuse happens at this layer instead. That clear waypoints. Maybe that happens there. But can you see that if we build this stuff on top of these things, that we would also have to put the same logic that we were creating here over in this thing here. To some extent, there might be some differences, but I think overall what we would be doing is duplicating some stuff there. But again, that's a nuanced discussion that you could have. But if you wanted to change, for example, how you create a widget, well, if you've done this, then that will impact this website, which perhaps it shouldn't have to. Maybe it doesn't have to. If we've got this as a NuGet package or a jar or a particular version of a DLL, this one might not, because it's a different application, it might not have to upgrade at the same time that this one does. But you still have an upgrade problem that will have to be sorted at some point. Okay, well that's a little bit of reuse, and I want to go a step further and talk about modularity because I see this quite a lot. A more extreme case is that developers decide and architects decide to decompose an API into microservices. But I think what we need to talk about in this circumstance is that, in this application, you cannot escape these dependencies here. You need the name of the widget and the name of the customer on this page. And, there might be some other metadata, we might have the customer number or whatever, or a stock code here, I don't know. But, there's no way that you can avoid on this transaction page having to load some extra data aside from the transaction itself. And what does that mean? Well, it means that this transaction form here and the self-serve site would have to either load from multiple services, or this transactions API would have to, what would that look like? I guess it would be this transaction form would call into customer. Bear with. Go to back. And it will also have to call into the widgets API. Okay. Or, perhaps this transactions API will call into these two APIs. That's ugly. I'm just going to give that a little bit of a zhuzh. I think that this kind of dependency is asking for trouble. You might introduce circular dependencies here, and then you'll have loops of calls which could get very expensive. Another option that we could choose is that these this transaction API could call into these two data stores directly, and fetch its own data. But now it means that we have coupling between the transactions API and the different data stores, and why are you trying to achieve modularity when it's impossible? And I think that people think of this as the solution, but I think that there are a lot of trade-offs in choosing this choice, and that's when a widget changes, we send a domain event and something I'm just going to imagine that as a a message queue, and we send an event, to the message queue when it changes. And that then provokes the widget table copy over here to be updated. We call that a materialized view, and there are different ways that you can do that, but I think that what you really need to understand, that the practicalities of getting this right, is that it's really, really difficult. Particularly with this stuff, you got messages that arrive out of order, you got messages that fail to deliver, messages that are delivered more than once, errors, delays, and I think that eventual consistency is a pretty good thing to aim for, but practically speaking, I think that this is really, really hard to achieve, at least with integrity. So be careful. I think enough said. So, okay, going back to the Prezzo. To sum up, reuse, it feels like a good thing, and I think that a lot of developers will agree with you, and it gives you some good things. It helps you to maintain code easier, but there are some dependencies that undermine the good things about reuse. I think I'm going to leave it at that. I'd love to hear from you, hear what you think about this topic. We could have a debate if you want, and I think that there's real room for a nuanced opinion about this, but maybe I've got it wrong, and if you have a different opinion, you should let me know. I'd love to talk to you about it. You can get me here at philipvoyle@hotmail.com, or on Twitter, or on Threads, or if you just want to see what code I've been writing, there's my GitHub there. Or you can like and comment below and we can have a conversation. Great. Talk to you next time.